Hello, protocols, packets, and programs. In the spirit of AppSec in 3 words, my intro today is sneakers, C-Tech, astronomy. Which means this week we talk with Vlad Matsiiako about tactics for keeping secrets, developers developing, and code compiling. Verify me and stay tuned for Application Security Weekly.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly. This is episode 327, recorded April 21st, 2025. I'm your host, Mike Shima, and I'm here with John Kinsella. Hello, John.
I'm here with the infamous Mike Shima. I must have done something right in life.
Either that or somebody, I'm trying to think of. Yeah, this is like you talk to those one guard lies, one guard always tells the truth. How do you solve that riddle? And you show up on a podcast. Speaking of maybe non-human guards, or identity at least, Identiverse 2025 is returning to Las Vegas, June 3rd through 6th. Hear from over 250 expert speakers and connect with 3,000 plus identity security professionals across 4 days. That's a lot of numbers. Covering the latest identity security trends. Take part in hands-on workshops and explore, this is my favorite part of reading this announcement, the brand new non-human identity pavilion. Who knows what's in there? Register now and save 25% with code IDV25-SecurityWeekly at securityweekly.com/IDV2025. Vlad Matsiiako is co-founder and CEO of InPhysical, the leading open source secrets, identity, and access management platform. And he's here joining us today. Hello, Vlad. Thank you for joining us.
Hello. Thank you, Mike and John. Thanks for having me. Very excited about this.
We're glad you're excited, and the topic today is secrets, and very more specifically, managing secrets, because there's a lot of aspects about them that could be made and go wrong. And I forgot to ask you off air if you could, for our listeners, share your password so we could explain what a good secret looks like.
Yeah, all my sticky notes, right? Yeah, this is how we manage secrets.
This is how we manage secrets, yes. But we are in a world where sticky notes are known to happen, as well as writing down passwords in notebooks, which I will say up front is not necessarily a bad thing, depending on your threat model and your memory. But if you need to share secrets, if you need to work with developers and you need to have a whole bunch of services talking to each other, running around with Post-its probably isn't going to work. So I think one of the things, rather than asking you what your password is, I do want to just ask, what kind of secrets are we talking about? Like, what are all these things that we need to keep secure?
Exactly, because I think when people talk about secrets, something that they think about first is just generally API keys and database access tokens, right? So kind of like very static type of credentials, like a token that gives you access to some resource or some service or some product, right, that you need to access in one way or another. And it's typically very programmatic, right? So that's typically the distinction between a password and a secret. Password is very much for kind of like a user type of authentication, and secrets are for machines and identities and more automated workflows. But really kind of like the rest of the secrets, there is much more than that, right? Because there is ephemeral credentials with how do you get access to database in a just-in-time manner. There are SSH keys, encryption keys, so certificates, right? And whole kind of like certificate authority lifecycle management. So there's all of these different things that you need to manage across your infrastructure. And so there's a host of problems that arise when you actually get to, at first, maybe kind of like for a small project, it's actually fairly easy because folks don't have too many secrets. But, at like very, very large organizations, it could be hundreds of thousands or millions of secrets that they're managing across all of their infrastructure. And
and a lot of those problems let's dive into what some of those problems are that you alluded to, because some of the secrets that you described, they're used for like SSH keys. This is used for remote access, API keys, typically for service to service access. And then if we talk about developers getting, obtaining code, committing code, and then this whole CI/CD process has a lot of just hopefully automated tools that are doing this. And one of those challenges is, and certs, that was the other thing, because some of these secrets are kind of long-lived. It used to be the case that certificates could be, 1 to 2 years, but you also mentioned ephemeral secrets or ephemeral access to the database. These are all lovely ideas on paper, but when you get beyond those, a dozen developers, maybe even with a dozen developers, it gets hard. So what do you pick apart of that list of like long-lived secrets, rotating, et cetera?
Exactly.
What are the harder parts there?
Yeah, I mean, I think the hardest part for organizations who decide to revamp or reinvent their secrets management at scale, the hardest part is actually not the tooling itself. In a way that you can get, all kinds of tooling. You can build it in-house. You can choose one of the vendors, right? There's so many opportunities that you have. The hardest part is actually convincing developers to use it day to day, because the main problem that organizations are facing is that secrets management is a very interesting kind of like part of security tooling, because it's both security tooling, but it's also infrastructure tooling, and it's used by developers day to day, and developers must use it to actually be able to have their daily workflows. And so really, if the solution that you're using is too complicated to use, it's like not really straightforward or not really simple enough for developers to understand, they'll just find some kind of workarounds, right? And then what happens is the organizations, they're using these tools, they purchase them for probably a lot of money, and they are not even realizing that their developers are not using them 100%. And so what happens is this creates a lot of these kind of like security holes that these organizations are not aware about.
And let me jump in there, because there's that aspect of the security team says you have to manage your secrets, you have to use these tools. But there's a big difference between you have to and they're easy to use, developers use it. And you were just describing developers will work around, or they'll do things that honestly are more efficient. This isn't to blame the developers, direction I'm going here.
Yeah.
So how do we get to the distinction between, cloud service providers do have secrets management that I think is relatively easy, but that's only with you're working within the CSP. What are those hard parts about trying to have a unified interface?
Because the reality of modern companies is that it's not just one cloud, right? It's potentially multiple clouds. It's different CI/CD platforms, could be GitHub Actions or GitLab CI/CD. It's infrastructure as code workloads. Maybe they're using Terraform Cloud. And so there could be a lot of these different pieces that creates all kinds of like point solutions that developers have to remember about and that developers need to utilize. And so really the problem is it's kind of like very much secret sprawl, where all your secrets are, in very separate locations, and you first of all, like, you don't even know how many secrets you have and like who has access to them and so on, right? But then for developers, there is not a clear understanding in their minds of like, okay, for this specific problem, what should they be doing, and what is a potential solution to this? And this is, once again, you're completely right. It's not the fault of developers, right? Because for developers, like, their main goal is to write code and ship the functionality, And so security is oftentimes kind of like a second concern for them. It's not something that they think about day to day. But if implemented correctly, that you can build the right program that basically has developers at the front, and then developers actually embrace it and they use it. They use these tools in day to day workloads.
And part of that, I want to maybe break down, what does it mean for, what does that ease of use look like? And part of the reason is that obviously we're talking about have developers use them, have developers adopt it and embrace, so that there's just a good security practices. And I want to use that as kind of a start to touch on, developers do come and go. People join companies, leave companies. How often does secrets management just help us have that one shared super secret that we have to rotate all the time? Or are there actually better patterns that we should be approaching here?
So typically how we think about it at Invisible is we actually think about secrets management from two different access standpoints. So the first access is about developers, right? It's from the day when developers actually join the organization. How do they get access to the right set of secrets? How can they get started with their work as soon as possible? And whether it's secrets or configurations, you can do it very fast. And in their local machines, they can run and compile the code and execute what they need. And then as the time passes, developers spend much, more time in different organizations, and typically depending on the industry, it could vary. Like for example, in banking, a lot of developers spend 10, 20 years at the organization. And so naturally, during this time, they work on a lot of different projects. They accumulate a lot of different access, right? Because every time you start working on a new project, you ask for a certain elevated access. It's granted to you typically because you need it, right? You're working on this new project, and then it's never really reevaluated, because in the case of an organization having like 1,000 or 10,000 developers, you can't really know live who has access to what, and do they really need that access or not? And so what happens is developers need all of these types of workflows. There's also workflows around change requests, right? Like if a developer implemented a new integration and they need to add a certain API key to the production environment, how do they actually let the admin of that environment know? And so typically what happens is that they, pass it through like email or Microsoft Teams, right? Where the admin, then very securely puts it inside the secrets management where it's probably secure, but the problem is the exchange is not secure itself, right?
Probably secure is going to be one of my new favorite phrases. Yeah. Well, and you hit here, there's two angles here that you touched on now. One is just the provisioning. How do we get the secret into the secret spot for the right people to access? And then, accruing all of this access maybe means there needs to be a rotation or not necessarily even rotation, just a time limit.
Exactly. And so, and that's pretty much kind of like the point of invisible, right? But you're completely right. First of all, there should be the rotation, ideally automated. Ideally, you don't even need to, we can talk about it in a minute, but ideally, you don't have these static secrets. But instead, when me as a developer or a certain machine or a Kubernetes cluster, when we need access to a particular database, you can generate the secret on demand, right? So it's not available there statically, but we can talk about it in a second. But yes, you're completely right. And so, but the other piece of it is also kind of like developer offboarding, right? So it's somewhere in the middle. Organizations typically face the problem of access over provisioning, where the access is just being granted, very frequently, and it's never really reevaluated. But then at some point, developers also leave the organization, right? And then the problem at that time is really, how do you understand what your risks are and which secrets can be rotated automatically? And that's great. But the problem is there is a lot of legacy secrets too, which they don't have. It's the reality of enterprise organizations, and they don't have the ability to be rotated automatically. And then the reality of what the company needs is just basically reports to understand like what are the risk levels for different environments, for different secrets that these developers have been exposed to, and what should be rotated manually earlier or later.
And so part of that is, excuse me, the rotation is this isn't the aspect of change your password every 90 days. Mm-hmm. Thankfully, the NIST SPs 863 A, B, or C, one of them came up finally, even officially said that's dumb. That doesn't there's rotate when there are meaningful events such as somebody leaving or has been exposed, etc. But we've touched on provisioning, rotation. I suppose there's some aspects of this we should come back to for sure. Just on the practices of secrets, but we also started talking about, like you mentioned, it's typically kind of an infrastructure team that owns the secrets management, building for developers consuming it. When something goes wrong, there's typically two questions. Was it DNS? Was it one of our certs? Yeah. And so we can set aside the DNS discussion for today, but yeah, a cert goes wrong. Yeah. This is an infrastructure team that, has a very critical component. So if we're, how does, I'm trying to phrase this best, how does centralizing all of your secrets into one service, ensure reliability or give you resiliency? Is that how often does that come up as a concern?
It's a very interesting question, because I guess to start with a little more background, right? Obviously, secrets management is very critical from the standpoint of security, right? Because the whole idea is that you try to remove secret sprawl and you centralize all your secrets in a secure location. It's encrypted, there is different levels of cryptography and encryption. That's great because it helps you unify all your audit logs, and your access controls are in the same location, so you can make them very tight, and you don't have this kind of like sprawl across your infrastructure. And so that's great. The problem though is, and it's very much kind of like how we talk about it from the infrastructure standpoint, is that a lot of your applications are now connected to the single point of failure, which basically provides secrets, and it basically creates this glue in between all the different services and clusters and pipelines that you have. And so if something happens, right, to your secrets management solution, well, that's a very big problem, because a lot of your applications could break, or they could go down, right? Or they could have cert issues, right? And all kinds of things. And really kind of like one of the solutions that's possible for this is basically splitting up the layer of storing, right? Kind of like encrypted secure storage in one place, but secondly, actually distributing across infrastructure. And so there is a lot of different things that we do within physical around caching, or around basically kind of like having more distributed workflows, where even if in physical is down or something like that, then your Kubernetes clusters or anything else could actually keep consuming the secrets efficiently.
And this is one of those areas. Oh, go ahead, John.
Yeah, I want to. We are an AppSec podcast, so I'm really curious to sort of dig into, shine that light back on you guys, for example, from what is it like from the point of view of you're running an application, which is probably one of the most critical things in a lot of companies.
Yeah.
I'm curious, like how much. I'm not looking for like an actual percentage, but like how much. I'm guessing you must go to a ton of effort to try and make sure this stuff is done right.
Yes. What you mean it done right in terms of reliability, or in terms of security, how exactly the integrations are configured with different infrastructure?
I guess I'm thinking, to sort of focus down a little bit, I'm thinking of you're a big fat target for an attacker.
Oh, yeah.
So how are you hardening the system? How are you doing AppSec? How are you doing, making sure that this is sort of impenetrable?
Oh, yes. I mean, so there is a lot of different components. Something else to say about secrets management, right, is that to this day, still, a very large number of enterprises using secrets management, they actually self-host their solutions. So because they want to keep it within their infrastructure, there's a lot of benefits for this from the security point of view, because the data never leaves, their own infrastructure. It's, even more so these days for European companies, because of all the geopolitics and kind of like not wanting to be in the American cloud as much. And it definitely comes up pretty often. But the benefit of it is that the data never leaves their own infrastructure. They are able to secure it much better according to their own standards, and their security team is actually able to have a lot of input into that. And on top of this, it also has a lot of reliability benefits and latency benefits, right? Especially for more kind of like very fast paced use cases, it becomes very, very good, because you're able to get your secrets live whenever you need them to, and there is no geographical delays or anything like that.
If I can ask, actually, along the lines of where John was going there, one of those aspects, talking about caching the secrets, and there are good strategies for being resilient should the centralized service go down. But once you start caching the secrets, you do start to have a different sort of secret sprawl. You just have the secrets sitting on a bunch of different distributed systems, so they're accessible, so they can be used. And there's also even just, here's a developer who might be the malicious insider, the malicious actor, or the developer's laptop has been compromised, and now you have a malicious actor on that laptop who's just requesting secrets. Yeah. And so that's one of those things. How do you go about, or how did you think about, someone just downloading all the secrets, obtaining them, or going through the cache and having basically that second copy of the management store?
So so that's a good question. Actually, the local developer machines are typically less of a problem in that sense, because typically the secrets that are available to be distributed to local machines, they're more from development environments. So they're much more kind of like configuration. And so we actually also provide a lot of different tooling that helps to make sure that these secrets are, you don't have them in your .env files, because that's still very much of kind of like the industry, let's say a very common tool used, right? And it's basically these static files where it's kind of like not a post-it note, but very much so, because you have all your secrets written down there, and hopefully they're not sensitive, but who knows, right? And so instead of this, we basically inject it directly in the application processes and help make sure that when the applications are exited, those secrets are also wiped out from the local machines, and things like that. But it's typically less of a problem for local development environments, and it's more so for different, for example, Kubernetes applications, right? And kind of like, how do you secure your clusters? And then it's much more. So typically, what we talk about it is it's much more of the kind of like networking problem, right? And how is your infrastructure set up, and whether it's private or does it have any internet connection, and so on. And it depends on if people are running it in the cloud or completely within their own data centers.
So what's interesting there is that, you've got that infrastructure team, just going to use that as kind of a little bit of our abstraction who owns this, but now they're not only experts on secrets management and encryption, protecting these, they're now SREs in the sense of that reliability, resiliency is important, and, network connectivity, network controls, boundaries, figure out who and what can access this. That all to me is interesting in the sense of you're putting a bunch of, intellectual domains, practice domains together from AppSec. Are there certain ways that you approach the design of the system to be more secure by design, more secure by default? And I'm using that as a bit of the large hand wavy phrases because those are the big ones. But I'm curious, how would you respond to like this is a secure by design approach for network problems, things like that?
So something else that I wanted to mention that I haven't mentioned yet, right, is because typically one of the biggest questions for organizations when using cloud native secrets management, right, is like who actually has the access to these secrets, right? And how is this infrastructure managed and so on. And something that's very neat that these organizations are actually able to do is they can basically bring their own keys for encryption. And so imagine if you're using AWS or GCP already, there is a key management service there. And so you can, or imagine you have a hardware security module in-house, from one of the vendors or something like that. You can actually use those to have these kind of like hardware-backed keys to be the different levels actually, not only on the root encryption, but they could be the backbone for encryption at physical. And so what this means is it provides a lot of capabilities for you. For example, let's say like a disaster scenario and someone gets access to your secrets management solution. Well, you can immediately revoke those keys and they're not stored within physical. So the attacker would immediately lose access to something and they would not be able to decrypt things anymore.
And so that also speaks to, one of my thoughts as we're talking about this is that, as John pointed out, we do focus on, AppSec. And that comes with the simple attacks like SQL injection, cross-site scripting. Those are so common. And we're curious about how software is designed and choices that go into that architecture. But then there's still just because the org hasn't made themselves resilient enough, someone clicks on a link and ransomware is now involved and all of your data is gone.
Oh yeah,
I don't know, how this specifically relates to secrets management, but I guess I'm just sort of thinking out loud in the worries here.
There are like these phishing attacks. I mean, it's so common, and that's also like, for example, for access over provisioning, right? Because if access over provisioning is there, then these attacks are much more dangerous. And versus if it's only just in time type of access, right, where people only have like a temporary nature, then it's much less of a problem because typically by default developers don't have as much access as they would have had otherwise. Something else though that's pretty nice here, and it's something that we haven't had a chance to touch on before, is that a lot of these problems are much bigger problems if you have static secrets, right? So it's basically secrets that are in your secure storage that are available there, and when I need it, or when a certain application cluster need it, we basically request those secrets, and then we are able to use them at any parts of the infrastructure where they need. Something else that you could do is you could basically set up secret rotation. So this is what we talked about before. It could be event-based, so it could be trigger based on something, right? So you could basically identify, if you accidentally hard-code a certain secret into Git, or maybe, in some other way it gets compromised, then you can automatically rotate their secret.
And so and I want to jump in because a lot of what you're describing there is not so much the AppSec of design, secure design of the application, the software. We're talking about secure design of processes. We're getting into that world of, honestly, compliance in the sense of how long-lived are your secrets? Does everyone get an ephemeral one? Is it static? And I'm curious there in the sense of, are there ways that you've put opinionated defaults into this to try to lead organizations into using what are probably what we would call, I'll be again a little bit hand wavy, here's the modern way of managing secrets. We prefer ephemeral for these reasons. Exactly. We prefer restricted granular tokens for these reasons.
Ideally, developers are not even able to store those static secrets, and ideally everything is ephemeral, and if you do need access, it's to the database. Let's say, first of all, you very granularly restrict it to a certain number of tables or fields or something like that. But then second of all, there is a workflow for developers to actually go through. And it's typically kind of like an access management type of workflow where developers are able to request access to the tools that they need, and then it's granted to them for 1 hour. And then they have this unique token that only they have, right? And other developers would actually have another unique token that's dedicated to them. And then based on that, in the audit logs, you're able to very clearly see what are the actions that are actually being performed.
Yeah, and that's what I guess to break down the security properties for our listeners is that saying ephemeral, saying per user is nice, but the reason is it can constrain what if that secret is exposed. You also now have a pretty good identifier that says, oh, this actually was Mike's secret associated with him, rather than somebody used the static secret and we're just not sure who. So there's that kind of observability logging problem that your incident response team is going to be appreciative of.
Exactly. It basically helps to make everything much more granular and helps define and basically get more granular with regards to the identity that's using those secrets.
How have you, one of the aspects, I want to go back a little bit to the idea of extracting secrets or, pulling them out, because one of the things that's potentially that would be there is that you describe, developers are having access to development environments, code, check into the CI/CD process, and then those services are obtaining and building and deploying to prod. And there's also that concern, that potential threat of, here is a Lambda that somebody has created, and that Lambda is in prod trying to pull down a bunch of secrets and then exfiltrate them, something like that. So how have you seen organizations, maybe this question is probably better about threat modeling. What are ways to threat model how to target a secrets manager?
Basically, how to understand if this Lambda is malicious, you're asking?
Yeah, or that's as one example. What are other ways that you threat model designing and creating, a secrets manager like this?
I mean, so it's a huge problem, right? And so it's all actually starts very much in the networking layer. And so how these Lambdas actually communicate, what they have access to, and so on. Who also from the outside, are people able to access your infrastructure? Hopefully not, right? And it's completely private. And there is no type of connection possible. There is a lot of different things that you can do on the secrets management layer with regards to restriction of what actions are possible depending on the IP address or different network ranges or locations or different other properties that you're able to take, whether from your identity provider or from some kind of other attribute mapping. And those attributes you're able to extract, and based on that you can build these types of dynamic policies that basically are able to identify if something suddenly changes and the Lambda that was previously calling secrets that was good is now compromised, and you're basically able to take those cues and identify if something is actually gone wrong.
So, and then what that makes me think of is more of yeah, I'm trying the why we have what the design is, why we have observability around this. And I guess I don't want to beat this part of the conversation dead. So let me do a quick pivot and ask, you mentioned at the beginning too, there were, small startups or large organizations, whether you have 10 people, 1,000 or 10,000 people influences this. I'm going to long sigh as I introduce this part. There's also Gen AI and LLMs and MCPs are a huge part of this. But my point here is more of there's now very much a sprawl of just services talking with each other. Does that change, or what does that change in this type of conversation?
Yes. So it changes a lot of things because now with Gen AI, we have a lot of agents, right, that are performing different workflows. And, typically agents are very much kind of like machine identities. But the thing about them is that they have a much wider possible range of requests that they're able to submit and a much wider range of actions. It's less deterministic, right? In a way that different functions that you code out in advance, they are able to perform certain set of actions, and then based on the access controls, you're able to decide whether certain action should be allowed or not. But with agents, it's much more unique in a way that every request could be slightly different depending on what the task at hand is for this agent. And so it basically magnifies all the sprawl issues that have been, that people have been having before, because now there is more of these agents and they're kind of growing exponentially, and there's just a lot happening in there.
There is. And I'm trying to make a joke now of just having LLMs choose their own passwords, and who knows what the heck that will be. But before we have to do our own rotation into a new segment, Vlad, we've been always asking our guests this year to describe AppSec in 3 words. And I'm curious what your response to that would be.
I think what I would describe it as is something like secure when simple, or secure when straightforward for developers, right? Because I think a lot of things that I've been talking about today is how to actually make it simple enough for developers to use and to follow all of these practices. And if it's too cryptic, if it's too complicated for them to use, they'll just find some kind of workarounds and they'll do their own thing. And so I think it's very important to keep developers part of the picture and actually have the buy-in from them on the very much kind of the mind share level across the org.
Yeah, I do like that theme of simple, just so that it's usable, that it's also harder to make mistakes, which is another thing that we want to avoid, that probably secure new catchphrase. Vlad, where can people find out more about you, or have anything coming up that you'll be speaking on, or something like that?
Yeah, I mean, lots of conferences. So anything security and infrastructure related, I would love to meet everyone. I'm on LinkedIn, so Vlad Matsiiako. Just add me there. And otherwise, stay tuned for all the InPhysical updates. We're releasing lots of new features around secrets management and things like that. So inphysical.com. If you have any questions, reach out.
Awesome. Thanks, Vlad. And thank you, everyone, for listening. Thank you as well, John. We're going to take a quick break now and return with news of the week. Welcome back to Application Security Weekly. We just talked with Vlad Matsiiako about the sprawl of secrets and what good properties of secrets look like. I'm your host, Mike Shima, and I'm here with John Kinsella, who looks good on ASW. And John, I'm glad you're here because we've got some news to go through. As always, that's not the big reveal, but I think the big reveal this week is I'm starting off with a news article that I really had to force myself to include. And so I'm going to take a long sigh. This is not the Gen AI LLM sigh. This is the article from...
All our listeners are eagerly waiting for us to cover this story. So.
I know. Let's build that anticipation for you good Rocky Horror Show fans out there. So the title is This is from NextGov. CISA extends MITRE-backed CVE contract hours before its lapse. And this was also a story broken, broken by Brian Krebs on security, who was talking about CISA was potentially losing funding, which means CVE MITRE was losing funding, and we're potentially going to lose CVEs, and no one will have any vulns to fix anymore because there will be no numbers for them. So let's move on.
So close to solving application security.
We were this close. Who knew? But and I think that I had that long preamble because part of me is, on a more meta level, I'm just not a fan of chasing a whole bunch of CVEs. That's not, I think, what healthy modern AppSec is. It's not just how many do we have, because so many of those CVEs are just low quality software quality bugs that aren't going to lead to a compromise. I'd much rather have those conversations that, honestly, CISA, also involved here, is talking about secure by design. What does that mean? What does that look like? Let's get rid of a class of vulns. But it was a big deal. We should probably at least acknowledge it. I don't know. Are you more excited about CVEs than me, John? Or there's the answer.
Excuse me. Forgot to mute my mic. You know what I was just thinking is the effort that MITRE has gone to over the last 8 years, I think it is, 5 to 8 years, to actually allow other organizations to be sort of sub-numbering authorities. Okay, so in this particular case, let's be very blunt and clear. MITRE's contract with the government is to manage a bunch of numbers. That's it. To make sure those numbers don't get used more than once. And there's other things, but that's really what it comes down to. So they started breaking out those numbers into subgroups, and they give some to GitHub, they give some to large vendors, they give some to other sort of locations.
Linux kernel, yeah.
Yeah. So my point there is, if funding did cease, how long would it take us to actually notice? Probably wouldn't be the year. So numbers are distributed on an annual basis. I'm guessing we could go months without even having anything noticed, beside all the other media is going like, oh my God, the sky is falling. But yeah, no, it's that's, and I don't know if some of our listeners think that we're sort of, being jaded and this is more important than we're making it seem, please do leave a comment and let us know. But
yeah, let us know.
Yeah.
Yeah, I don't want to undersell it, but I will acknowledge the fact that there are some of the aspects you alluded to are just, the industry doesn't want vendors to sit on that 90-day coordinated disclosure. I prefer that over responsible. They don't want vendors to sit on a vuln and not let it be known, so that you do need that third party to report to. But I think, as you said, tracking numbers, I will also add, I love that we just have numbers and we haven't gone down the APT naming route. And here is the fluffy penguin, or who knows what. We can spend the next half hour coming up with fun names, but just keep that CVE 2025 12345. That I appreciate the most. Let's keep that. So let's move on. Let's see how many other CVEs come up in the rest of our news, though. One thing that did catch my eye is I've been reading Trail of Bits blog quite a bit, and here's a sneak peek for a new ASN.1 API for Python. So again, this caught my eye because it was about parsers, and ASN1 is one of the most weirdest, horrible contraptions ever created. There's a long history of just especially in OpenSSL world and the certificate world, of just those parsers having buffer overflows, having weirdness, ambiguity, as well as having the AS1 standard be self-contradictory in many ways, which is not something you want. So, long story short, what Trail of Bits did was they said, oh, look, there's a bunch of different Python-based implementations of how to parse this, and having different parsers act in different ways can go bad. We saw this with XML parsing just a few weeks ago in Ruby. But what caught my eye was they didn't just re-implement this in Python. They re-implemented the parser in Rust, primarily for performance reasons, and going to be aiming for correctness, things like that. Just let's re-implement a parser. But it did make me wonder: are we going to see is Rust going to sneak in like a cuckoo into Python, into NPM, into Ruby? And rather than let's rewrite this for performance in C, we'll rewrite it in Rust because Rust is the memory safe cool kids language this year.
it will be interesting to see. It feels like one of those use cases where I haven't looked at the code, couldn't tell you who's writing it, so I'm very sort of off, haven't looked at this closely, but there's a sense to me at least that there's a good chance you're putting too much trust into like, Rust, right? Particularly for this, if it's just that first introduction to a package, is someone going to call it incorrectly? Or are they going to do memory mismanagement outside of, or data mismanagement outside of the Rust call? Or it's like, it feels like the blessing of, we have used Rust, we are secure. And I'm not saying that they're saying that, but I just hope they're careful around that.
Yeah, and it goes back to one of my other favorite soapboxes is to point that example of here's a vuln in Rust-based or memory safe code that was not a memory safety issue. And yeah, exactly. And what's interesting, they're pointing out that X.509 and ASN.1, just to throw out fun letters and numbers, is, their SigStore is using a lot. And a lot of crypto, as in cryptocurrency, are using a lot of certificates. So there is maybe they never went away, but there's perhaps a renaissance or a re-embracing of certificates and extending these properties of certificates that are based on ASN.1, which are important for figuring out, are we parsing them correctly? It is basically, here's the other way to say this. The attack surface of these is growing, so it does seem appropriate to be paying attention to that. I'm not going to say it's bad to redo this in Rust. It just strikes me as a curiosity to see what the trend will be for hardening our infrastructure. Go take a breath. And John, you mentioned, I mentioned hardening just now, but you mentioned like the secure design approaches. There's another article I grabbed that was a security audit of PHP source. And this is from the folks over at Quarks Lab. And it was funded by the OSTI, Open Source Technology Improvement Fund, which is trying to look at a lot of different open source tools and help elevate the security of them. Now, what I liked about this is that it's a simple, short write-up, but it says it's a combination of, here is the point in time security review we made, but we also went and did some improvements to the SAST tooling and built some fuzzers. So not only do they have a point in time look, this is what the code is, it's secure, maybe secure, there's a couple findings on this particular day, but they left behind a couple tools that hopefully have an ongoing quality improvement impact, positive impact to the PHP. But one of the other things I was saying is when I mentioned when we were talking about the Python and ASN.1 parsing, you're talking, I think, a little bit about APIs, using the APIs, using it correctly. There's a long list of findings here about OpenSSL within PHP, and just a bunch of different ways that, none of them are high, but a bunch of different ways that OpenSSL's API was just misused, et cetera, et cetera. And I don't know if that struck you more as, is there an OpenSSL problem here or a PHP problem here?
I don't know about you, excuse me. When someone hands me a pen test report or a code review report, step one, anything that says info just gets immediately ignored and I'm never going to look at it again.
Fair, yes.
I think that's about half the list. Step two, I'm going to go to the highs and actually figure out, oh, Jesus, when am I actually going to be able to get these fixed? The mediums, I'll sort of ponder how long I can get away with before I get them fixed. And the lows, like, I don't know, it's April when recording. I might look at these maybe around September, October, when my team has a little more bandwidth.
Yeah.
And I'm being sort of facetious when I say this, don't quote me on this, but like not too much. So OpenSSL lows, it is interesting that they found several in there. It feels, I'm not filtering my words. It feels a little sloppy if they suddenly found it. Obviously, whoever was going over this saw one thing, and he looked closer to OpenSSL code, and he said oh, they're actually doing this multiple ways. It could be improved. So it's good they know it. Good they know of it, and now they can improve it next September, October. Two things caught my eye about this. One, for folks who haven't requested or ordered a code review or pen test. I like some of the sections they have at the top saying like, hey, here's the key tasks we were assigned, right? So the key basic things we're going to go through, check out the tooling, look for how can we improve the SaaS, look at the fuzzers as we were talking about earlier, the crypto and manual code review. Hey, so that sort of caught what was going on there. Then the high priority tasks. So like, hey, after that, you sort of look over the general thing. These are the areas where we want you to look. So a little more in my background, I'd call it targeted code review, right? So we got some questions about that MySQL native driver, JSON parsing. We know it's always a pain. Can you guys go through that and double check it for us? OpenSSL again. So that was something they called out. So I like that they're highlighting that what they've been asked to sort of poke at more closely. Again, for those who don't know, and I'm sure a lot of you guys do, so excuse me for going through this. If you give someone an unbounded code review, it could take them right as long as they want to go for it. So usually you want to bind either off the amount of time you want them to spend on, or the budget, how many dollars you want them to spend on it. So that's where you sort of focus people. So maybe next time they do this, they might focus on another area. But I think that's sort of interesting for people to think about, like even at your company, right? Or your maybe it's your class. If you have like 5 hours, where are you going to spend it on the code? Are you going to look at everything overall, or do you have that funny sort of spidey sense of, I got this funny feeling like that one area where it writes out to a database. Did I see hard-coded credentials in there? Or like, right? So then you go and look at that area. Yeah, so I'm glad you're doing this. PHP is still unfortunately alive and well out there. I'm not sure, Mike, when is the code review coming for Perl? That must have happened. I don't remember covering it, though.
That's April 1st, 2026 is going to be my prediction.
That would be fun.
But I wanted to echo a little bit of what you said. Don't need to repeat because you said it very well. But to sort of, my angle was those high priority tasks are a good example of a threat model and meaningful attack surface. Like those are good areas that you would look at, as well as meaningful attack surface. Speaking of, do we rewrite this in Rust, for example? I'm not saying that PHP is going to become Rust again, but those are areas that if a lot of those high and mediums were just this long slew of memory safety issues, buffer overflows, heap overflows, et cetera, then you'd start to say, maybe we do actually need to either rewrite this code entirely or rewrite it into a new language because it is not salvageable. And the one thing that stood out for me, because there were, 3 medium findings for OpenSSL, and then 1, 2, 3, 4 for low related to OpenSSL, and then, yes, not to take away from the work, but a bit of a yawn, just another 4 for related to OpenSSL and the infos. It just makes me wonder, if we were to rewrite, the back end of OpenSSL into Rust and memory safety, I don't think I would keep that API. I think it feels like you need to rewrite the OpenSSL API because look how easy it is just to misuse. And maybe there's a little bit of pedantic attention here on correctness, but that's a good thing because correct code, I hope, is more quality code, which is more secure code. But it just feels like it's an API that's easy to misuse for OpenSSL, and that's probably one of its bigger sins.
So 2 thoughts on this before we move on. One, I think it was The Onion a few years ago had an article about people were starting to put Starbucks within Starbuckses. So like, right? And I'm sort of wondering, what are these weeks we're going to come on here and we're going to say, hey, someone decided to write some Rust within Rust. But on a more serious note, as you were talking through and sort of combining the thoughts here between the pen test, I keep calling it pen test, the code review, focus versus where do you use Rust, I think there's an interesting, at least to me, sort of cross there of like, hey, I guess the question is, the statement is there's more than one way to use this focus at the top, the key task, high priority task, extra consideration. You could use this, you could spend the money here and say, hey, we think there's some weaknesses in libSSL or in the JSON parsing. So do you go and pay someone to review that, or you go, hey, you know what, let's go and pay the Rust guy to just rewrite it? And I think that's sort of an interesting thing there, right? It's obviously not that easy. You have to have the expertise in your company to support that code once it's done, or open source project, whatever. But yeah, if I'm going through and focusing and trying to figure out like what is the where do I want to spend the money on my code review, and I write down functionalities related to passwords in X standard password.c. Maybe I might want to rewrite that in Rust or pick your language, right? It's like, I don't know. It just sort of occurred to me there as we're talking through that. And I'm not trying to, take money away from the code reviewers, but there's multiple uses for that, having that process of going through and figuring out what to focus on.
Indeed, and there's one of the aspects too. There's a phrase I love. If you go out into the wilderness, one of the state or national parks, there's a common motto: take only pictures, leave only footprints. To try and riff on that a bit for a review like this is more of, take only a little bit of time on ephemeral, to use that word of the day, security reviews, but leave behind fuzzers. Leave behind something that is an ongoing work. And you were talking about, what do you invest in? If I approach that answer as well, or that question as well, I would invest in the fuzzers, just because that feels like a favorite thing of mine, but a way to help with quality over the long time. We're going to switch now to, I don't think there's a CVE related to this, but there is a blog post. This is from TrustWave about Pixel Perfect Trap, the surge of SVG-borne phishing attacks. And I'm hoping that I know I worry that I put you to sleep talking about CVEs. I don't want to put you to sleep once again talking about just phishing, but there's a couple takeaways I want from this blog post. One, image-based XSS is kind of fun as a novelty. 20 years ago, you could put XSS payloads into the EXIF data of a GIF or a PNG, and this will date it, but like your Netscape browser would parse it. And kind of things haven't changed too much. As the blog post explains, SVG is a image, it can render images, but it can do so by calling JavaScript, for example, or it can call out to foreign functions of JavaScript. And that just basically becomes, here's another link to click on. Some of the article, though, was not quite rubbing me the wrong way. I understand that there's some marketing aspect to blog posts like this, but it was a little bit framing like, oh, look how users are fooled into clicking on a link, or look how security tools aren't paying attention to base 64 encoding, or basically just hand wave and say just rot 13. If your payload is rot 13 and your security tool doesn't know how to open that up, or it's a zip file, et cetera, it's failing. And that's what I wanted to touch on a little bit, in the sense of all of this phishing. It's obviously still working, long sigh, but it does feel like the security industry, security tooling, and just people designing systems can be doing a better job of, why are we even talking about SVGs as, executing JavaScript in the first place? The same with PDF can execute JavaScript, but the readers are locked down. So yeah. So
sorry.
Yeah, that's the best I can do. Hopefully you've. I'm here to entertain you.
When your SVG, you're doing a great job today, Mike. When your SVG has the ability, your SVG parser has the ability to execute JavaScript, something's wrong. I was just sort of skimming through this. I'd read it earlier, but to me, it feels like this is something. I don't think this was written for us.
Fair.
So, and thanks for the giggles, guys. But okay, it comes back to that. Who are we framing this for? Is this for management? Is it for I thought it was sort of interesting. What really sort of caught my eye is that they've got the code for the SVG sample code, and then showing it rendering into a Microsoft logo. I think for a lot of people that'd be like, oh, that's what this thing is that we talk about, right? It's not just sort of showing here's the compromise code or whatever else, but when we talk about SVG, what is that? Why is this such a big deal? Well, there is literally text, and that's part of what makes this something that has to be parsed. And then we end up in a world where people are talking about SVG phishing. It's. We've probably been saying this for a few years now, but when's the end? There's going to be. I think we're not seeing around AI because there's really not AI data that's being pushed around yet to be able to click on. There's some ODAs out in iOS again right now that aren't patched around parsing of, I believe it's media files. I think it's videos. It's just sort of for drive-bys. That came out, I think, Friday or Saturday. So it's still, never ends. And it's like, think about it, like Apple has some pretty good coders, right? And a lot of stuff. They obviously have some very good coders, but my point here is they're spending a lot of money to have these people write the software correctly, and they're still having issues. So, yeah, it'd be nice if, I don't know, what's the Rust for media parsing? Someone create that.
Someone create that. And I'm glad you mentioned the iOS example, because it does make for an easy segue into one of the articles. This was from a Risky Bulletin newsletter. Android looks set to get its own lockdown mode. And the reason I bring that up is you mentioned ODAs and media parsing. Any user-generated content plus a parser is going to be potential for shenanigans. And on the one hand, yes, there is memory safe code, Rust, etc. But there's also other things that iOS has been doing with their blast doors technique about isolating processes, making it possible so that when there is that unexpected buffer overflow, what happens, that the attack surface is smaller, or this process doesn't share the same memory as your secrets that are sitting there, your credentials. What's nice about this is that, what was it, 2 or 3 years ago that Apple started this, and now competition seems positive for security and for users. Android is creating its own lockdown mode. I think in this, we can touch on the secure design elements of it, but part of this is also there's a user experience that, who is this for? In the sense of, if you're a journalist, if you're an activist, if you're more security savvy or UX savvy, or sorry, not UX savvy, or just tech savvy, you might understand why you would need to do this, or what the implications are that, you enter lockdown mode and suddenly a lot of your memes images aren't rendering automatically. And that's disappointing, because everybody wants to see cats. So it's there's a combination here of, long story short, once again, of good security design, but there also has to be backed by good explanations to the user about, is this for me? What are the consequences? Will I get locked out of my own account? And I think that's probably one of the biggest concerns that anyone will have. If I make this more secure, but I drop my phone or I lose a FIDO key or something like that, can I ever get back into it? So that's where my head was going, thinking about the user experience, and but also thinking about you, John. I'm not sure if you're happy about seeing this type of lockdown mode, or it's getting your mind thinking about something.
I am, but first I've got to have an unfortunate path that I followed here while you were talking. I got excited for a second. I went out to shenanigans.com, and I'm really disappointed with what I found there, and I'll leave it for listeners to go see. It's WorkSafe. Where do I go here? So let's see. You're talking first about, you made a comment about the user experience for who would be using this, and it's poor Android users who, for whatever reason, don't have an iPhone. Haha, sorry guys. But yeah, that's an interesting one. I mean, me, the security nerd, how often do I turn on the lockdown mode on my iOS device? Not very often. I mean, sometimes it goes for long periods of time, but I don't switch back and forth very often. I'll leave it as that, to be slightly OPSEC-ish. I like the idea. One of the thoughts I had as you were talking through that also is Android hardening guide. Just that series of words, and we were for a while riffing on hardening guides and why do you need them and should be by default and blah, 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 blah. The point here is we can't have it on by default because the world wants to see those cat videos or cat GIFs. So it's good they have this as a fallback. I mean, I guess it's like, I think that's sort of maybe what people should be doing. If a vulnerability comes out, it's like, how do you use this, right? To sort of drill down into is I think what you're trying to do. If I don't know, pick your number. I mean, hell, you could actually, well, okay, the security nerds could set this up. So like if there's a new CVSS 8 or higher, automatically switch my phone to lockdown mode, or the less nerdy, slightly less nerdy version of this, if I can talk, would be if when someone's sending out like these vulnerability announcements going like, hey, this is out there, you probably want to put your phone at lockdown mode until this is patched. And And I think that could work for a lot of devices. I'm just thinking like, even me in the house, how often do I tell my wife, hey, there's a new vulnerability out there for your X. You want to go and patch this pretty quick. Sometimes I will, sometimes I won't, right? So it's when do you tell people to use this? To circle back to what you're saying. And I think the other interesting aspect is, and I skimmed through this one, I think they're thinking of this just for phones, but think about all the Android things in your house. Android TV, I've seen it in thermostats, it's in cars. There's a fun one. Do you want to put your car into Android lockdown mode? Yeah, I don't know. It feels like it's the beginning of something, and I hope they keep sort of going with it because it has potential.
It has potential, and it feels like one of those things that, as you point out with the hardening guide, it's unlike the phishing in the sense where, hey, dear user, just be aware of all of these things. Pay attention to what the latest CVE numbers are and their CVSS scores, and don't click on links. It's not putting all the burden on the user. It's informing the user by saying, if you make this choice, or if this is your threat model in different language, if you are worried about this scenario, or if you're worried about this situation, lockdown mode will help you by doing this. And so it's more of that. The device has a more secure design that has negative user experience, negative consequences in some ways, but better security consequences. And so that's why I'm a fan of this and not a fan of just telling users not to click on that link. And then I'm also a fan of fun articles and silly things that go on. This is not too much of a security application security tie-in, but there's an article from TechCrunch about Silicon Valley crosswalk buttons hacked to imitate Musk and Zuckerberg's voices. And so on the grand scheme of things, it's a bit of that reminder of IoT, OT, all these connected devices, distributed devices. They're important to keep secure. There are things that could go wrong. This is just one of those examples of hacktivism. I haven't heard that term in a long time. I don't know if that hacktivists and hacktivism still is around. It falls a bit more on the silly, less consequential side, as opposed to other things that are possible with this. But it was funny, but kind of let's move on. And I don't want to dismiss it because I don't know. Let's just leave it at that. For me, it was fun.
Yeah, I'm sort of, so there was a version of this up here. Early last week, apparently there was some crosswalk signs downtown Seattle playing Jeff Bezos's voice. I haven't seen them myself yet, but I wonder, it's sort of like, there can't be, I mean, these things, it's a crosswalk button. So it's fairly hardened. It's designed for lowest common denominator. I'm guessing there's not a USB port on it. I'm just sort of curious, like how do you actually get into the thing? I don't want to try it myself, but like, hey, if I happen to find one cheap on eBay or something, maybe that could be fun.
That will be maybe this DEF CON, then one of the hardware hacking villages, or one of those villages, we'll have some more information on this, because some of the technical aspects would be really fun. How do you take this apart and add your own voice there?
They're on eBay, at least some of them. I don't know if it's a talking version, but I see them for like, it has to be like, there we go, $80 to $120, $130. Hey, got some potential here.
Well, for our video listeners, video watchers, there's some solder behind you, so your lab is all prepped for some hardware hacking, John.
It might actually get used for the first time in a few months, but yeah.
That's awesome. Well, John, this is not the first time I've seen you in a few months, but I'm glad to see you on week after week. So thank you for joining us. Thank everyone else for joining us as well. Please do remember to subscribe. Check out the show notes, share on the socials, and speaking of fighting for the users, check out Warrior by Starwave. We'll see you next time on Application Security Weekly.